for our third and last example of our first lesson on optimization, let's look at this. So a professional basketball team plays in an arena. So if I'm thinking of Budweiser Gardens, let's say, average attendance at each game has been about 14,000 people. So actually that got me thinking, I thought the capacity of Bud Gardens was around 10,000. I just looked it up. It's actually just over 9,000. So obviously we wouldn't be able to fit 14,000 people. So let's go ahead and think of like the Raptors then, right, in Toronto. So average attendance at each game is 14,000 people. The average ticket price is $75, which is probably more in line with what you would spend to go see the Raptors, probably pre-playoffs. Market research shows that for every $5 reduction in the ticket price, so every time I reduce the ticket price by $5, because everybody wants to pay less money, right? The attendance is going to increase by 800 people. So just for example here, if the ticket price was $70 reduced by 5, I would have 14,800 people coming. If it was reduced again to $65, I would have 14,800 plus another 800 people coming, right? So at that price, right, think it's not just individual, but when you're going, you're usually going with someone. So if you're a couple or going with your brother or sister, if you were to take your whole family, you know, that's 75 times 4 or 5 tickets, or at least times 2. Most likely you're going with somebody. So that might turn people off from going. Maybe they can only go once a season then, right? If that. So when it becomes less, it's less for that many more people. People are more enticed to go. So what we want to find out is what price, and this is a very typical real life question, right? What price will maximize revenue? They really only care about making as much money as they can by who's coming to see the game. Doesn't necessarily mean that the venue has to be full, because maybe the venue won't be full at that particular price, but that they are making the most money, bringing in the most revenue. So we're going to need to write a revenue equation, right? So what is the question asking? It's asking us to maximize revenue. Then we want to optimize that. Then we want an equation about that. So we want a revenue equation, and then we're going to get the derivative of it. So I have to determine what my variables are going to be. So obviously we're talking about reducing the price. So let's let X represent, I can't say let X represent a $5 price reduction, because it might be happening more than once, right? Every time I reduce it $5, I'm gaining another 800 people. I'm selling another 800 tickets at $75. So I might have to reduce that price twice, or maybe 3 times. So let X represent the number of price reductions. The number of, I could even say $5, right? Because I'm always reducing it by $5 for this question. And what else? What would my other variable be? So I've got the price, then I need to have, what am I trying to do? I'm trying to maximize revenue, right? So I'll use R for that. I could have used Y, I could use anything, just makes more sense. Let R represent the revenue or the maximum revenue, and that's going to be in units of dollars, obviously. So my revenue equation, what's the calculation for revenue? How do I calculate revenue? Revenue is equal to price times quantity. What am I selling it at times how many people are buying it, right? So for my revenue equation here, I have to be careful. My price is starting at $75, but it's not going to stay. I'm trying to play around and change my price. So it's going to be $75 minus $5 price reduction. How many times am I going to have a price reduction multiplied by how many times I do that? Because if I have 2 price reductions, then 2 times 5, right? Then I'm minusing $10 off of 75. So does that hopefully make sense? And then my quantity, right? I'm starting out with 14,000 people in attendance. And every time I decrease the price, I'm increasing by 800 people. How many times am I going to increase by 800 people will depend on what my X is. How many price reductions I have will depend on how many times I'm increasing by 800. So that's my revenue formula, price times quantity. Now, I guess first would be, if you see here, I only have one variable. I don't have two variables like in the previous two questions. So I don't actually have to get a second equation, and then I don't have to use substitution. So that's kind of nice about that. Now, the first thing you might think if I see a binomial multiplied binomial is, why don't I go ahead and FOIL this, right? So I'm just looking ahead here and seeing if I FOIL 14,000 times 75, my numbers are going to be quite large. So is there a way, I mean, I totally can, but is there a way to differentiate maybe without getting into those large values? Can I get the derivative of this? I can use the product rule, right? And I can go right into the product rule without using FOIL. So I don't think I would use FOIL for this one. So the product rule, again, just to go over it just for short here, is to take the derivative of the first term and multiply it by the second term. And don't forget, product rule is adding, we've been subtracting with quotient, adding, I can't fit it here, so I'll just put it down here, the derivative of the second function, again, multiplied by exactly what the first term is. Okay, let's differentiate. Get R prime. Let's do this. Derivative of the first would just be -5 then. Multiply by exactly what's there for the second. 14,000 plus 800x, and then I'm going to add to that the derivative of the second. The derivative of the second would just be 800. Multiply that by exactly what's there in the first term. 75 minus 5x, and in this case there is no divide by anything, right? So what I can do is clean this up, bring that -5 in, bring the 800 in, and then we're going to set that equal to 0. So 14,000 times -5, I have -70,000. 8 times 5 is 40, so you've got a 4 with 3 zeros, so that's going to be a negative, sorry, minus 4,000x plus 800 times 75 is 60,000. A plus times a negative, negative again, 4,000x. And we're going to set that equal to 0 and clean that up a little bit. So I've got my -70,000 plus 60,000 would be -10,000. And I've got my -4,000x and subtract another 4,000x, -8,000x. And again, now that I have it set equal to 0, I can solve for x. So to solve for x, again, I can just bring that 10,000 over to the other side, right? And solve for x that way. Divide by -8,000, divide by -8,000. And I have x equals a negative number here, -1.25. So, X represents what? X represents the number of $5 price reductions. So if the number of $5 price reductions is negative one time, 1.25 times, what does that mean? So just to write down here, therefore my critical number is at x equaling -1.25, right? Anybody figure out what that means yet? Sorry, I didn't write down negative here. Therefore, my critical number is at x equals -1.25. So again, negative means I'm not doing a price reduction. I'm doing the opposite of that. I'm actually increasing the price by $5, technically 1.25 times. So that would be a little bit more than $5, right? So I want to confirm that this is a maximum though, that I'm maximizing revenue, doing the second derivative test. Here is where I think I'm running out of room. So I'm just going to clear this and rewrite this first derivative here. R prime equals negative 8,000x minus 10,000. I'll just rewrite that. R prime equals what I just said, negative 8,000x minus 10,000. I want to get the second derivative, the derivative of that, which again would just be negative 8,000, right? Because then x to the exponent of 0, constant's derivative is 0. So then if I plugged in my critical number, negative 1.25 in for x, again, I don't have an x value there. It's a constant, so it equals negative 8,000. Negative 8,000, all I care about is that it's less than 0. So again, concave down with a frown, which means it's confirming that I have a max. So I do have a max at x equals negative 1.25. So now I can go to my conclusions. Go back to what the question is asking. All it asks is find the price that's going to maximize the revenue. So we want the price that's going to maximize the revenue. My price, if you go back to my, just over here off to the side, my revenue equation, right, was price times quantity. And if you remember, the price part was 75 minus 5x, then times the quantity. So I'm going to use that as my price equation and plug in my x value. That's giving me a maximum. Bed mass, multiply first, so that's going to be 75. There's our plus, turning it into a plus. So it's actually increasing it by $6.25, they figured out, is $81.25 per ticket. Well, actually, again, the seats may not be full. I will actually have less than 14,000 people in the stands, right? But I will make more money than I would even if the seats were full and I decreased the price. So sometimes that happens. That's why in business, you really need to look at these numbers in order to make money. So therefore, a price of, find the price, that's all I have to do. Therefore, a price of $81, that's where I put my dollar sign in my therefore statement, and 25 cents will maximize revenue. And the question could have went further and asked you to figure out maybe how many people that would have been, but this particular question doesn't.